Hey guys, we're going to review Unit 4 before you take the test. Hopefully you've already turned in your study guide. If you haven't, go ahead and do that before you watch the video, please. And I'm going to apologize if you hear a little bit of craziness in the background. My dogs are underneath me and they're kind of arguing with one another as I go through this. So I apologize for the kind of grunting noise in the background and the ball dropping on the ground. That is my puppy and my big dog playing with one another, but I'm going to go ahead and get through this. All right, so vocabulary. This is the main vocabulary that is on here. I'm not going to read through each one of these, but if you want to stop the video and look through these and make sure that you know these, they are important for you to know, so you can take a moment to do that. Let's look at the practice. So why do elements form compounds? They form compounds because they want to be stable, and they are stable with 8 valence electrons. So here we go. Let me try to get this. Remember, 8 valence electrons. 8 is kind of the magic number. Now, if we go on and look at the second practice, so using the chemical formula, you have to be able to determine how many of each type of element are in the compound. So in the first 1A, you've got 1 calcium and 2 chlorine. Notice that chlorine has a little 2 beside it. That means there's 2 of them. Calcium does not have any beside it. That means that there is 1 calcium. So you can kind of go through and look at those. I did not give you one as complex as C, so you do not have to figure out kind of the distributive property with the parentheses. I did not put that on there, okay? Now, I also did not put number 3 on there, so we're not going to really stop and spend time on that one. Now, this is all online, so you don't actually have to draw any of these, but just realize what is going on here. In this particular example, potassium is transferring an electron to iodine. So this is an example of an ionic bond here. Aluminum is transferring 1 electron to each one of these bromines so that bromine is full. So we do the same thing when we kind of crisscross and reduce. So for example, aluminum is +3, and bromine, sorry, that is my puppy. That's my puppy. So you end up with AlBr3 when you crisscross and reduce. Or you can draw the Lewis dot with the number of valence electrons, and you can see that everybody ends up being full. The using of the charge just makes it a little bit easier to figure that out. All right, so let's go on and look at ionic compounds. So ionic bonds are made up of a metal and a non-metal, and they are transferring electrons. They're not sharing, they're transferring. Now remember, when you are naming ionic compounds, you don't have to be very specific because they can only come together one way. You're basically just telling me what the compound is made up of. So it's made up of sodium and it's made up of chlorine, but we change the end of the second element, or the end of the non-metal, to IDE. And I've got those written on the chart that's on the left-hand side there. You can see all of those non-metals with IDE on the end. We do not take into account the prefixes. Sorry, y'all can say hello. That's Macy. That's my grand dog, and she likes to bark. Okay? No prefixes. All you got to do is put IDE on the second one of ionic compounds. Stop. All right. Number 7. When you are writing the formula for ionic compounds, they don't tell you what subscripts you need. So what you have to do is you have to crisscross and reduce. So potassium and chlorine. Let's look at this example first. K is +1, chlorine is -1. There is a 1-to-1 ratio there, so you're going to end up with KCl. Okay? Now let's erase this one and go on and look at the next one, and it is calcium chloride. Okay, so calcium is +2 and chlorine is -1. You're going to end up with crisscross and reduce. You're going to end up with CaCl2. Now forget about the plus and the minus, you just want the number. This is going to make it a neutral compound. Okay, let's go on to the next one. And we have aluminum, which is +3, and bromine, which is -1. So you're going to cross over. The 1 is going to go with aluminum, and the 3 is going to go with bromine. And you see what you get, AlBr3. Okay? All right. I'm going to show you here in just a minute. I will go over and we will look at a periodic table so we can kind of go over how I found those charges again. But it's up at the top of your periodic table. That's where you find the charges for the different elements. Now, we are looking at covalent bonds. This is another vocabulary word that you need to be familiar with. Covalent bonds are sharing electrons between two nonmetals. All right. Now, if you look at these characteristics of covalent compounds and ionic compounds, we also want to talk about metallic. But covalent compounds have low melting and boiling points. They do not conduct electricity. Ionic compounds have high melting and boiling points. They are solid crystalline structures, and they do conduct electricity when they are dissolved in water. Remember that metallic bonds are bendable, and they conduct electricity. All right. Now, when we're naming covalent compounds, we have to use the prefixes because you can have many different compounds that are made up of the same thing. So notice that we don't use mono on the first element, but we use tri on the second element, and we put IDE on the end. These prefixes are going to be given to you. Do not try to crisscross or anything like that. You've just got to be more descriptive when you are naming covalent compounds. And then on the last one, all you've got to do is use the prefixes and don't do any kind of crisscross and reduce. Just assign the prefixes to the particular atom and write it down just like it is written. So dinitrogen trioxide, N2O3, sulfur dioxide is SO2, dinitrogen monosulfide, N2S, and then the last one is B2H4. Think we can handle that? No crisscross. Don't try to look it up on your periodic table. Just use the prefixes that are either on your foldable or on the board in front of the room. Okay, so let's go through and look at a periodic table real quick. And I think I have got one. If y'all give me just a second, I'm going to go over to just another periodic table that I have. Hold on, that one's going to be confusing. Let me see here. No, that's not the one I want. All right. I am going to just have to show you, I'm just going to draw on a blank sheet here and kind of show you the periodic table. All right, so you remember you've got this. This is your periodic table here. We've got this. We've got it going down, and then we kind of come across, and we go back up here. All right, so remember, every element that is in group 1 has a +1 charge, and then we've got +2 on this second column here. And oh, my lines are horrible, but you'll get the idea. We got +3 right here. Now this column right here says Na. These guys don't form bonds, so we're not worried about the charge. Then we have -3, -2, and my scale is not going to be right here, -1 for this last one. And then you've kind of got 0 here for these these are the noble gases. So you get the idea. Just look at the top of your periodic table, and that will show you what you need. Let's go back and look at this study guide. So what I'm going to do is I'm going to scroll through here, and you stop on whatever you think that you need more practice with and look over it, and then when you get done you can take the test. And just look back up. There is covalent bond. You might need to study that a little bit more. Don't forget to crisscross and reduce when you're writing ionic compounds, naming ionic compounds. And if we go on up through, I want to stop here on the vocabulary. I think it'd be a good idea if you spent some time looking over that. Okay, guys, do well on the test. Spend a few more minutes looking over this if you need to. And just take your time on the test, and I will see you guys on Thursday.